So this video is over algebra representation, focusing on the rules, the algebraic rules. So let's expand this. So the rule 3x, where x is her brother's tickets, can be used to find Jamie's number of tickets. Make a table to identify the number of tickets Jamie has when her brother has 40, 50, and 60 tickets. Then graph the order pair. So has her brother has 40, 50, and 60 tickets. According to this, Jamie has 3x. The relationship is 3x. That means 3 times the x. And what is x? X is a variable. A variable is a letter or symbol that really represents a number. And the number they gave us, 40, 50, and 60. So she has 3 times that number of tickets that her brother has. That means she has 120 tickets. She has 3 times the number of tickets that Jamie has. That's 150 tickets. 3 times, if Jamie's brother had 60 tickets, she has 3 times that number. That means she has 180 tickets. So let's graph this. So if Jamie's brother has 40 times 3, that means she must have 120 tickets. If Jamie's brother has 50, then she must have 150 tickets. If Jamie's brother has 60 tickets, then she must have 180 tickets. So what happens if Jamie's brother has 0 tickets? How many tickets will Jamie have? 0. What if Jamie has 10 tickets? Then she will have 30 tickets. What if Jamie's brother has 20 tickets? Then that would be 60. 30 would be 90. So as you can see, it would be a straight line. But do we connect it? No, because you cannot have half of a ticket. That doesn't make sense. So list the independent and dependent variables and quantities. This is the x-axis, and this is the y-axis. So you can manipulate Jamie's brother's ticket. If you manipulate Jamie's brother's ticket, then Jamie's ticket responds to that. So some of you in 6th grade science may have learned it as dry mix. Jamie's ticket depends on how many tickets Jamie's brother has. So the independent is Jamie's brother tickets. The dependent would be Jamie's tickets. So the numbers for that Jamie's could be 10, 20, 30, 40, 50, 60, 70. While Jamie's tickets would be 30, 60, 90, 120, 150, 180. Write a statement explaining the relationship. Well, it seems like Jamie has 3 times the number of tickets that her brother has. Jamie's ticket depends on how many tickets Jamie's brother has. So that's my statement. To find the number of tickets Jamie has, you've got to multiply her brother's tickets by 3. And her tickets depends on what her brother has. So our next thing is called Miss Nelson is Missing. And Miss Nelson is Missing, this is a story about Miss Nelson. She's a very, very nice teacher. And however, her kids do not listen to her. And so as a result, a substitute teacher named Miss Viola Swamp took over, and she demanded respect from her student, and she got it. So as the story proceeds, Miss Nelson had one kid, who did 13 spitballs. He rolled it up and he launched 13 spitballs. Then we had 2 little boys, and these 2 little boys farted 26 times during story time. Then we had 3 students who went to the kindergarten hallway and splashed 39 kindergarten kids. Shame on them. So that one kid did 13 spitballs. Two kids did 26 farts or flatulence movement during story time. Three kids splashed 39 kindergarten kids. So what is the relationship rule? Can you figure it out? Is it adding? Are we adding? Let's see. Are we adding 12? No, but 2 plus 12 is not 26. So I know we're not adding. So let's erase this. Is it multiplicative? We multiplying by 13. I think we are. So it seems like the rule is times 13. So if you know the number of kids, you can multiply by 13, or 13 times the number of kids are 13K. So the expression is 13K, or 13 times the number of kids. I mean, they do 13 bad deeds per kid. So according to the table, how many bad deeds will 8 kids do? So 8 kids times 13, 8 times 13 would be 104. Count the number of students in this class. At the same rate, how many bad deeds or behavior will this class do? So we had 20 bad kids in this class. Not that they would do anything bad. And each kid does 13 bad deeds. That would be 260 bad deeds. List the independent quantities shown. Independent. Succinct. Independent. If this is the x-axis, we graph it, and this is the y-axis, the number of bad deeds depends on the number of bad kids. So the independent is the number of bad kids. Number of kids. Because if you manipulate the kids, then the bad deeds will respond to it. Next part, graph it. So all right, let's graph this. This is X and Y. So X is bad kids. We have to label first. So these are the bad kids, or number of them. And this will be bad deeds. One kid does 13 bad deeds. You know what? I think we're going to have to add 0 here. Now, one kid does 13. 0 kids do 0 bad deeds. 2 kids would do 26. 3 would do 39. 4 would do 52. 5 would do 65. Do we connect the dots or not? I'm going to say no, because you cannot have a fractional of a bad deed. You know, the teacher gets really mad and they want to split them, but no, you cannot. So which variable represents the dependent? So looking at it, which one would be the dependent? The dependent would be the number of bad deeds. It is multiplicative because we had to multiply by 13. It's additive multiplicative. And what is the rule? The rule is you multiply the kids by 13, and that's how you will know the number of bad deeds. So the second part of our lesson, now that we understand something about relationship between the dependent and the independent variables, is sequence. A sequence is a list of things, usually numbers, that are in order. 3, 5, 7, 9, 11, 13, 15, 17, 19. So use words and symbols to describe the value of each term in relation to its position, and find the value of the 9th term in the sequence. So if we start with 3, and the value is 11, start with 4, the value is 12, start with 5, the value is 13. What is the relationship? Is it additive or is it multiplicative? Well, what can I multiply 3 by to get 11? I'm not really sure. 4 times 3 is 12. I don't think the relationship is times 3 because 3 times 3 is 9. So you know what? I will need to erase this. I think it's additive maybe. Plus 8 plus 8 plus 8. It is additive. So we're adding 8 to the number, these numbers, and plus 8. So if we needed to find the ninth term, we add 8 to it, it'd be 17. Next one. What is the relationship here? 5 to 45, 6 to 54, 7 to 63. I believe the relationship is times 9, so it must be multiplicative. So we're multiplying n times 9, 9 times n, or 9n. To find the ninth term, you need to multiply by 9, so the value will be 81. With a partner, identify decide which one is the independent and the dependent. So this is the x-axis. When we graph this, this would be the y-axis. So this manipulates, while this depends and responds to the manipulation. So the independent would be cups of sugar. And the dependent would be dozen of cookies. So the dozen of cookies depends on how many sugar you have. So 3/4 becomes a 3. 1.5 becomes a 6. 2 1/4 becomes a 9. 3 becomes a 12. I don't know about you, but I'm going to start with the whole numbers here. I think it's times 4 because I know if you had 1.5 is 4, that would equal 6 because you turn the mixed number to an improper fraction and then you multiply by 4 over 1 and you get 12, 2, or 6. So the relationship is times 4. So it's 4 times the cup of sugar, or 4s. Next one, miles driven. What's the relationship here? Seems like it's plus 4 plus 4 plus 4. The relationship is additive. So we're adding 4 to the miles, m plus 4. So if this is the x-axis and this is the y, the independent would be miles driven. The dependent would be the gallons used. Because the gallons used depends on how many miles that are driven. If you manipulate the miles driven, then the gallons used will respond to it. Next one. Let's see. If this is the x-axis and this is the y-axis, I mean, the independent would be the number of weeks. The dependent would be the growth. So let's see, a 1 to a half, a 2 to a 1, a 3 to 1.5, a 4 to a 2. It could be divided by 2. So we're dividing the week, we're dividing by 2. That could be one of them. What's another way to say divide by 2? We can multiply by what fraction? If you do the reciprocal of 2, then it'll be multiplying by a half. So it could be half of the number of weeks. Half of the weeks will show you how much it grew. So if you have 4 weeks, half of that, it grew 2 inches. So the growth depends on the number of weeks. Last but not least, what is the relationship between slices and total cost? If this is the y-axis and this is the x-axis, that means the independent is the number of slices. The dependent is the cost. So what is the thing? 2 slices cost a $3.50. I believe each one will be $1.75. Like 2 goes in. Subtracting this, can 2 go in 15? 7 times. Our remainder is 1. Bring down to 0. Can 2 go in 10? 5 times. So the relationship is times, a multiplicative. So if we know the number of slices, We multiply it by $1.75, and we'll know the total cost. That's one way to write the expression. You can write it as 175 times number $1.75 per slice, or $1.75. So this is our algebra representation